Hello everyone, I am Sunil Kumar and in this video I am going to talk about the recurrence relation, how to solve the recurrence relation using substitution method. So let us try to solve the given recurrence relation. Let's say this is our equation number 1 and we want to simplify and we want to find the time complexity for t of n for this recurrence relation. So see in previous video we have tried to find the value of t of n by 2. So first we will try to find the value of t of n by 2 and then we will replace, we will substitute. So how I can find the value of t of n by 2? So let me write the equation number 1. So it is going to be 2t of n by 2 plus n log base 2n. So what I can do in this question, so if I replace this n by 2, then I'll get the value of t of n by 2. So let us replace, so if you substitute, so it is going to be n by 2 and equal to, so 2t of it is going to be n upon 2 square plus, so it is going to be what, n by 2 log base 2 n by 2, because we are replacing n by 2. So it is going to be okay. So let us substitute in this equation. Let me start from here because it is going to be lengthy, I think. Okay, so 2 will be as it is, then plus n log n will be as it is, n log n. Now let us replace this value. Let us substitute the value of t of n by 2. So what is the value of t of n by 2? Now substitute in this question. So it is going to be 2t of n by 2 square plus n by 2 log n by 2. Yes. Okay, so if you further simplify this question, so it is going to be 2 square t of n upon 2 square plus, so it is going to be ultimately n log n upon 2 plus n log base 2n. So let us substitute one more time in order to understand the series. So this time I want to calculate the value of n upon 2 square. So what I will do, I will simply replace n by n upon 2 square. So now this time I am going to replace. So see what is the value in this next, so it is going to be ultimately n upon 2 square equal to 2t of n upon 2 cube plus n by 2 square log n by 2 square, and this is going to be base 2. So let us substitute this value. So it is going to be 2 square. Now let us substitute. So let me write this series as it is. So it is going to be n log base 2 n by 2 plus n log base 2n. Now so what is the value of t of n upon 2 square? So it is going to be t of n upon, let me pick marker. So it is what, n upon, it is going to be n upon 2 cube plus n upon 2 square log n upon 2 square, n upon 2 square. Okay, so let us further simplify this. So it is going to be 2 cube t of n upon 2 cube plus it will be cancelled, so it is going to be ultimately n log n upon 2 square plus n log n upon I can write 2 raised to power 1 plus n log n upon 2 raised to power, so this is base 2, and let me write 2 raised to power 0. If I divide this n by 1, so it is so it will not affect. So 2 raised to power 0 is nothing but 1. So I have written, because I think I am getting one pattern, so that is the reason I have divided by 2 raised to power 0. So if I continue one more time, so I'll get 2 raised to power 4 t of n upon 2 raised to power 4 plus n log n upon 2 raised to power cube, because here it is 3, then here it is 2, so definitely it is 4, then it is going to be 2 raised to power 3. If you are having any doubt, so you can substitute the value. So plus n log n upon 2 square plus n upon 2 raised to power 1 plus n into log n upon 2 raised to power 0. So now, so up to what term I should continue? I should continue up to kth term. So what will be the value? 2 raised to power k, so t of n upon 2 raised to power k plus, now my next term would be n into log n upon 2 raised to power k minus 1 plus it is going to continue up to what? N into log n upon 2 raised to power 1 plus n into log n upon 2 raised to power 0. So I have not written the middle terms, so you can write down. So see now, so it is going to be ultimately, let us replace, let us assume n upon 2 raised to power k is what? You can assume 1. So n equal to 2 raised to power k, if you find the value of k, so it is going to be log base to n. So 2 raised to power k is what? N. Now into t of, so t, so this value is nothing but n upon 2k is what? N upon 2 raised to power k is what? 1 plus, so you can take n common from this series, so it is going to be now, so you can write down, so it is what? Log n upon, let me write in reverse order, so it is going to be n upon 2 raised to power 0 plus log n upon 2 raised to power 1 plus log of n upon 2 raised to power 2 plus it will continue up to what term? So last term is so log n upon 2 raised to power k minus 1. So this is what my last term. So see, so it is going to be ultimately n into t of 1 is what? So you can consider t of 1 is what? 1. So this is the termination condition. So n plus n into what? Now see, so this is what? Nothing but log a upon b is what? Log a upon b. So it is going to, you can write log a upon b is nothing but, you can write log a minus log b. So it can be written like this. So let me write in this way. So it is going to be log n minus log 2 raised to power 0. So 0 will come this side, so ultimately it is going to be 0 only. So let me, okay, so this is going to be what? So this is okay, so plus next term would be what? Log of n minus log of so it is going to be log of 2 raised to power 1, correct? So now you can write down. Next term would be definitely log of n minus log of 2 raised to power 2. So this is what the next term. So but last term would be what? Plus log n. So let me write last term here. Maybe you are not able to see. So last term is, I am writing here dash dash plus log of n minus log of 2 raised to power k minus 1. So this is what my last term. So okay, so let us find the value. So let me remove this. Let me remove all this. Okay. Now see, so what is my last term? So it is nothing but n plus n into, now see, if you simplify this, so it is going to be log n minus, so 0 will come this side, so it is going to be ultimately 0, so minus 0, this is going to be 0. Now next term would be what? Plus log n minus, so this 1 would come this side, so 2 raised to power, so it is, let me write, simplify this, so 1 will come this side, so it is going to be log 2 base 2, so ultimately it is going to be 1 only, so you can write like this. Next term would be log n minus, so it is going to be 2, it is going to be 2. So see, let us try to understand what is the last term. So if I replace this ky log n, so let me replace this ky log n, so it is going to be I can replace here also, so it is going to be what? Log n minus 1. So last term is what? Log n minus log base 2, so it is what? 2 raised to power log n minus 1. So this log n minus 1 will come this side, and it will become 2, it will become 1 only. So let me rewrite this. So it is going to be ultimately last term would be only, so I'm writing the last term, so it is going to be log n minus, so this will come this side, log n minus 1 will come this side, and this log 2 raised to is going to be 1, so you can multiply with 1. So if you simplify this last term, so it is going to be what, ultimately log n minus log n plus 1. So it will be cancelled, and previous term was definitely, if it is 1, then previous term is going to be, let us assume this is this is current term plus 1, and previous term is going to be 2, and previous term is going to be 3, and it will keep continuing up to what, last term is what, log n. So last term is log n. So this is what the series we got, and now let us multiply with n also, plus this n is as it is. Now let us solve this. So it is going to be what, now n plus n is going to be, now this is nothing but the, let me write 1 plus 2 plus 3 in reverse order. So it is going to be a continue up to log n, log n. So let's suppose now see, so what I can write, if it is 1 plus 2 plus 3 plus 4 up to n. So what is this, what is this series? This is nothing but the sum of series. So we can write n into n plus 1 divided by 2, divided by 2. So but in this case last term is not actually n, last term is log n. So simply you can replace this n by log n. So what would be the series? So it is going to be n plus n. Now you can simply replace, because last term is not n, it is actually log n. So you can replace this n by log n. So it is going to be log n into log n plus 1 divided by 2. Now if you further simplify, so it is going to be n plus n into, so it is going to be log base 2 n square. So it is ultimately time complexity is what, n log base 2 n square. So this is what the time complexity for this given recurrence relation. So this is very interesting question.